Doke. Let's get it. We're gonna do two different methods here. I'm gonna show you the long way, and we're gonna do it the short way. Now, the short way can be done, I'd say 90% of the time, but sometimes you have to go the long way. This next problem, we don't have to go the long way. We can do it the short way, and I'll show you how to do it the short way, which I know you will prefer because it's less work. But you got to know that there's another way, and then in the videos as we progress, I will do one where you will be forced to go the long way. You'll have no choice. So let's check it out. That is not the problem. That's the problem from last time. Oh, golly. Let me put this one in. Yeah, just a little x squared plus 2x minus 1 doesn't factor. We have our 2x cubed down below plus a 3x squared minus a 2x. Sorry about not being prepped. Still had your last problem, man. Come on, man. Be better. So let's continue to talk about those degrees. So up top we have degree 2. Down below we have degree 3. So if the degree is larger in the bottom than it is up top, PFD. Not much else we're going to be able to do. So let's get it. We're going to need to, each and every time, most of our work's going to be done out of the problem. So we're going to need to take this, and we need to factor our denominator. So I can see we can take out an x, right? There's an x on every term, so that leaves us with 2x squared plus 3x minus 2. What is this? So just in the interest of time, I'm going to assume you know how to factor and just go through. So this ends up being 2x minus 1 times x plus 2, right? X plus 2. That goes with this, that goes there. Yes, we're good. Okay, so we know that this is going to break down into some sort of terms. We're trying to add some fractions, but we're going in reverse here. So we know that there's three numbers we're looking for, some A, some B, and some C. And we want to set it up that way because these antiderivatives are very, very simple. You give me a number over x, it's just a number times negative or times the natural log of x. Yeah, it's not so bad. So we want to set it up in a way that's easier to deal with. All right, so then our next step, do you remember it from the first video? We're going to multiply by this denominator on both sides. So since on the left-hand side, it just cancels perfectly, we end up here. And then when we bring it in, I'm not showing all those steps. You can see that the x will cancel out, correct? You'll see that the x will cancel out, and that'll just leave you with the 2x minus 1, x plus 2. Next, we're going to have our b. So when we bring that in, the 2x minus 1s will cancel. You'll be left with b times x plus 2. Lastly, we're going to bring it in here, and now we can show it. The x plus 2s will just cancel out, leaving us with c times x times 2x minus 1. Okay, here we are. Now we're trying to solve for a's, b's, and c's. Now there's a simple method, and then there's a more challenging method. So I'm going to go down for the longer methods, and I'll do it down here. So what this is we actually have to take all of this stuff and expand it out. Excuse me. So we're going to end up with 2x squared plus 3x minus 4. Minus 2. Sorry. Oh my goodness. Minus 2 plus b times x squared plus 2x plus c times 2x squared minus x. Man, I'm struggling. Okay, this is the long method. Now again, this one you don't have to, so you might want to just speed this up if you feel like it. But now what ends up happening is we want to equate our coefficients. Notice we have an a times an x squared, a b times an x squared, a c times an x squared. So I'm going to bring this thing out. So we have 2ax squared plus 3ax minus 2a. Let's bring them all out. There's a reason why I highlighted the blue too. So you're like, why are you doing all of this? Because soon we're going to need it. Now here's the game. We want to take everything with an x squared and put it together and factor out the x squared. So let's see what we got. For our x squared terms, we have a 2a, we have a b, and we have a 2c. Why do I keep writing a 1 on the x squared? I don't know. All right, next, let's go deal with all the things that just have an x. So we have 3 terms, so it looks like, let's take the x out. We have a 3a, a 2b, and a minus a c. And then lastly, we're just left with this minus 2a. Here is the game. We are going to what we call equate coefficients. 1 must be equal to the coefficient on x squared. Therefore, 1 is equal to 2a plus b plus 2c. Next, we're going to say 2 must be equal to the coefficient. 2x must be equal to the coefficient of 3a plus 2b minus c that's on the x. So we say 2 is equal to 3a plus 2b minus c. And lastly, we're going to have our negative 1 must be equal to our negative 2a. Now you're going through a system of equations. You go and solve for a, you plug it back in, and now you have what we call a 2 by 2. And then you can go solve for a, b, and c, and then we can do the rest of the problem. That's the long method. It will pop up where you're going to be forced to do this. But we like to be efficient. Don't you? I like to be efficient. So the way that we had learned before, if we just choose a value of x, like, I don't know, let's choose x equals 0. Know what I mean? I think we're going to be able to go through and solve. So, all right, so when x equals 0, on the left-hand side, we just have a negative 1. Now, of course, these are just going to go away, right? Because we're going to be multiplying by 0. So you're going to have a times, well, 2 times 0 is 0, so you get a negative 1 times a 2. So we found out that a is equal to, well, negative 2a is equal to negative 1. Oh, weird. That's the same thing we got down there. Therefore, a is equal to positive 1/2. Let's do it again. Let's check out, now what do we want to choose? What's a good value of x to clear everything out? I'm thinking maybe, let's go with negative 2. You know, negative 2 and negative 2, that's going to kill the a and the b. So let's go with x equals negative 2, and let's see what happens here. So we're going to need to plug in negative 2 over here. So negative 2 squared is 4. Oh, minus 4. Oh, so we get minus 1 is equal to, well, the a goes away, the b goes away, and we're just left with the c times negative 2 times 2 times negative 2 minus 1. So what do we have? Oh, negative 2 times negative 5, that's negative 10. So c is equal to 1/10. Cool, cool, cool. Wait a second. That's a negative and a negative. That's a positive. Hold on. That's a positive 10. Come on. So c is equal to negative 1/10. Now we're going to go through and let's get rid of all this. Give some room. And now we go through and we find b. So what value are we going to go plug in for b? To get b. So that means we want, oh, what's that, a half? And a half is going to kill the a and the c. So now let's set it up. So when x is equal to a half, we're going to have, what is that, 1/2 squared, just dealing with this side over here, plus 2 times 1/2 minus 1 is equal to, we already know, that's going to cancel, that's going to cancel. So we're going to get b times 1/2 plus 1/2 plus 2. Getting rid of that stuff. Don't worry, we're almost done. We're almost done. So we're going to get 1/4 plus 1 minus 1 is equal to, what's that, 5/2 times 2. So 1 times 5 is 5. So we get 5/4 b. Those just cancel out. So we get 1/4 is equal to 5/4 b. Let's multiply by its reciprocal. And we're going to find out that b is equal to 1/5. Whoo! We did it! Oh my goodness. Algebra. That's all we did. We did frickin' algebra. That's all we did. We have not done calculus yet. So that's 1/2. That's 1/5. That's -1/10. Now we can begin doing the integral. So this is equal to, I'm going to call it 1/2 times 1 over x plus 1/5 times 1 over 2x minus 1 minus 1/10 times 1 over x plus 2. Now let's solve this integral. Let's go. Let's go. So here we are. So we're like integrate. So we get 1/2 the natural log of the absolute value of x plus, now we got a little bit of a tricky thing. Do you know how to find this? And I'm going to skip it. I'm going to hope you can see it. We have there's a 2 inside of there. You typically need to do a u sub and divide the 2 out. So 1 over 5 times 1/2 is 1/10, the natural log of 2x minus 1. Hopefully you see that. You can do a u sub and check it for yourself, but I don't find any need. Oh, why am I still running integral? Come on, man. And then we have minus 1/10, and then we get the natural log of the absolute value of x plus 2, all plus c. And that's our solution. How long did the calculus take? I know I showed 2 different methods here, but these problems are long. Really, no matter what you do, and they're tedious. Full disclosure, I did this problem before doing this yesterday, and it actually made me stop making videos. It was like I got the wrong coefficients. I made a silly mistake. It happens. So we just want to go through, get as much practice with it as possible. Yeah. And I will see you in the next video.